So the real issue is I'm not going to give an expose on the climate issue. I'm just going to try to pick the points that are important for an economist. And for that, I think this is a very recent review of evidence in the IPCC report, just published, I think, a couple of days ago. And then, of course, there are the Nordhaus and Stern reviews that are considered as some kind of the landmarks in the field. Okay. This is the first important picture. What we are dealing with is that we have some radiation from the sun. Radiation from the sun is bounced backwards and it changes to some extent in nature, in frequency. And the result of this is that some of this radiation is blocked by the atmosphere around the Earth. And that's actually a phenomenon we need to have a decent temperature on the Earth. What happened is that this atmosphere, this layer the concentration in this layer of what we call greenhouse gases. So the greenhouse gases that we need to keep Earth at a certain decent temperature. This concentration has been increased a little bit too much, and this gives results as a result, some kind of climate warming. What we say climate warming is actually distortion of the climate system. Of course, you can go, if you like physics, you can go in a lot of detail here, and it's very interesting. But I think for most economists or for most policymakers, they, from the moment they know this basic figure is actually taken from the frequently asked questions of the IPCC, one of the IPCC report people go on. Okay, now there are 5 crucial relations. First one is that human behavior is at the origin of extra greenhouse gas emissions. That's number 1. So we distorted some kind of the carbon cycle of the Earth. So there's normally a carbon cycle where there's a certain capture of carbon, there is a release of carbon by the ocean, we have all the forest, we have land, all these interacts, and we created some kind of distortion. This distortion has mainly to do with the use of fossil fuels, so carbon dioxide, but also methane, and a few other greenhouse gases. That's the number 1, okay? So if it had nothing to do with human behavior, okay, maybe we still have a problem. We can still try to do something about it, but this is really important to realize. The second thing which is important is this accumulation in the atmosphere. We have many environmental problems where we have too much air pollution at some point. The wind is there, it blows away, and the next day we start again from zero. This is not the case here. We build up a problem, we accumulate a problem, and when you accumulate a problem, it will be important. It will not be sufficient to stabilize emissions. We really have to decrease emissions very strongly. The third point is that the increased concentration. This concentration will decay to some extent over the years. It traps heat, generates global warming. Global warming generates climate change. And again, here, what is important is a certain delay of 20 to 50 years. I always compare it with a bathroom. When you try to heat the bathroom and there's a lot of cold water in the bath, the cold water in the bath will delay the heating of the temperature in the bathroom. So there's some kind of thermal inertia under mainly oceans, delay this warming. And this means that whenever you change this concentration and you think, I've done something, you will see the results in probably 20 to 50 years. So there is a delay in the effects you can notice. Final point, climate change generates damage. It also generates beneficial effects, but we are mostly concerned about the damage. Now, we usually say, these economists, whenever they make prediction about 20, 30, 40 years, they have no clue. They really make big mistakes. But when you discuss with scientists, climate scientists, they agree that they also have a lot of uncertainty about each of these relationships. Okay. This is an illustration that the greenhouse gas concentration has gone up as a result of industrialization the last 100, 200 years. Now, what makes climate change a difficult problem for the world? Okay. And I think there are kind of 5 properties we need that are important. The first one is that effects are complex, uncertain, and differ by region. Effects are delayed by 1 or 2 generations, 20 to 40 years. It's a cumulative pollution problem. Every ton emitted will accumulate and generate effects for the next few hundred years. It's a global pollutant. It's not if we reduce pollution or emissions in Europe, it will have beneficial effect for the whole world. Of course, for every ton we generate, we also generate damage in the whole world. And it's not an easy fix. So for some previous problems like stratospheric ozone was an easy fix in the sense that we could replace some chemicals and reduce these effects. There is no such magical solution. So we had also rather easy solutions for acid rain. There's no such easy fix for climate change. Okay. I'll let you have a look at this type of nice illustration coming from IPCC, where you see that, so they illustrate mostly the adverse effects. And they also illustrate to some extent the confidence in attribution of certain effects to climate change. Okay, so you see sometimes it's low confidence for damages to key economic sectors. And there is high confidence on other elements. Okay, so it's a lot of uncertainty, and of course these uncertainties have been reduced over the years, but there is still a lot of uncertainty. Some people compare this problem with a tipping point problem on these different graphs. So you have on the y-axis, you have some kind of health of the economy or ecosystem. And on the horizontal axis, you have some kind of the temperature, okay? And it could be that you start with, original equilibrium that is not too bad, but just by stressing climate change, pollution, deforestation, you change so much the climate system that you end up in a completely different system, and a system that is locally stable and is at bad equilibrium. Okay, the effects are delayed by 1 or 2 generations. I'm 70, so I will not experience, let's say, most of the effects of the emissions I created myself. But if you're born in 1980, or if you're born in 2020, you will experience these effects. And so if you look, I don't know whether you see my pointer. You see my pointer?
Yes.
Yes. Okay, perfect. Thank you. I was not sure because. So what you see here is that the more reddish it becomes, the higher will be the temperature, the higher will be the global warming. And if you keep emissions very low, you will not experience so much effects of global warming. But if they're very high, we risk really very high temperatures, very high increase in temperature, 4 degrees, 5 degrees centigrade, which is a lot. So it's up to 4 degrees centigrade. Okay, it's a cumulative pollutant, and it's very often forgotten because people say, yeah, we will stabilize, it will be okay. No, because if you just stabilize, you will continue building up the problem. And that's important nuance to see. So if you want to reach a certain objective in 2050, you will, and let's say, try to stabilize at the present level of global warming, you really need a very strong emission reduction. Excuse me. Where are the emissions coming from? That's also an important point. Mainly energy use, deforestation cannot be forgotten. And we should also not forget that we have an economy, or we have a world that is growing in terms of economics. If you want the poorer countries to have a reasonable income, they need to grow. And some people think that the economy may be 3 times as large in 2050 than it is now. So this means that per unit of GDP, per unit of product, you really need to reduce emissions very strongly in order to reach a given, in order to reach an important decrease in emissions. Okay. Okay, this graph tells you what are the annual emissions for the world. And the ambition of Paris Agreement was 1.5 degrees centigrade. If we do everything well, probably we will end up with 2 degrees centigrade. Pledges and targets are actually the promises that have been made in Paris in 2015. With current policies, we are not yet at these pledges, at these promises made in Paris. And if we really have no policies, we end up really, we keep growing an economy that is growing, and we keep increasing the emissions. Okay. Where are the emissions coming from? And usually it's an important point. I think most of us here are from Europe. So Europe is now responsible for some 8% of total greenhouse gas emissions in the world. So even if we reduce emissions in Europe up to zero, okay, I don't say it means nothing, but it's only a small part of the total emissions, and the same holds for, let's say, North America. Even if North America and Europe make a lot of efforts and reduce emissions to zero, it will certainly be insufficient. So we need to turn to other countries, and then if you look at the other countries, usually you start to have a discussion on the historical emissions. And in this part of the graph, you see the historical emissions. Because that usually, if you discuss with developing countries, they say, yeah, but who is responsible for the problem? Yeah, who is responsible for the problem? Mainly North America, Europe, Eastern Asia to some extent, Latin America, but not Africa, not Australia, etc. Okay, so even if you weight it by per capita, this is for 2019 already. So Europe and North America, at least Europe, made an effort. North America is still on the top here. You have Eastern Asia, okay, mainly China. But you see, per capita, there's very strong divergence. And if you want to agree with other countries, of course, if the other countries are low emitters, they say, yeah, okay, but we are not responsible for the problem. You should act. Okay. So it's an important dimension, and it's important to know the facts. Okay. Not an easy fix. To what extent? Yeah, okay, it's mainly have to switch. First, line of defense would be to switch between different types of fossil energy, so switching from coal to gas, then adopting new technologies, renewables, and then to some extent reduced consumption of carbon-intensive goods. Usually, you will need to efforts in all sectors and in the whole world, which doesn't make it very easy. How do you do that? What is the relative importance of different sectors? I will not dwell on that. So if you're interested, have a look at this very condensed figure where you see where food production is important, manufactured products, mobility is important, and electricity generation is also an important source of emissions. Okay, where is the hope? The hope is to some extent that the cost of new technologies has been going down a lot. The best known example is photovoltaics, onshore wind, batteries for passenger electric vehicles. Now we have to be careful because let's say these graphs, they tell you it's going down, but it will not necessarily continue to go down. It could very well arrive on a plateau over here. Okay. So there's some hope, but it remains costly because, okay, we need to develop these new technologies, we need to install them, etc. Certainly, if you want to do it quickly, it's a problem. Then you can say, as an economist, some economists like to optimize strategies, and then they start to say, let's compare the cost and benefits of action for the whole world. And then you have actively two schools. One approach is more like via quantitative target. Let's say the precautionary principle, say let's avoid big problems and go for avoid warming and make sure that we stay within the 1.5 degrees up to 2 degrees centigrade. But you can also go the other approach and say, okay, what we should try to do is take into account what we call the marginal external cost. What is the cost? The damage we create for the world as a whole for every ton that we emit. So every ton that we emit will damage the whole world and will damage the whole world for the coming generations. So you will see if you try to make these computations, this is an illustration taken from science, you will see the role of the discount rate. If you really have a high discount rate, it means that you do not pay too much attention to the very distant future. And you end up with a low total damage, discounted total damage. While if you go for a much lower discount rate, you end up with a much higher discounted cost of 1 ton of CO2. Okay, we surveyed here these 5 important characteristics.